Hello, this is Shakil Ahmed. In this tutorial, we'll discuss about independent sample t-test and pair sample t-test and how we can perform these tests in Python. We can the data on stroke patients with different variables, starting from demographics and some clinical variables and some other social demographic variables like work type, residence, and so on. So I have just uploaded the data here, stocks.csv. If you have not uploaded, you can upload using this from your computer. I have stock CSV data here, so I just uploaded it here. And then you can run the import pandas SPD and you can read your data using read.csv. You don't need to give the path as you have already uploaded the data here. If you have not uploaded data and your data is on Google Drive, then you need to set the path through content. And then we can see first few rows of the data set. And again, if you want to generate the code with this data frame, you can use this option and you can see the recommended plots and you can uh, create new interactive sheets using this option. Here I'm just creating a box plot as we are going to compare the two groups, the two independent groups. And we want to see the average glucose level differs by gender. The average glucose for male. So we need to test this hypothesis. Then we can just see here visual display using box plot. We can just use the px box plot ly and express. So this will be the X as gender and Y as the average glucose, and it will give a box plot by gender. You can see we have three gender categories: male, female, and others. So we can see the average glucose level is a little higher in males as compared to females, and we will test this through the independent sample t-test. So here we can see there is a slight uh, positive skewness in the average glucose for both male and female. You can see the numbers as well, the maximum number, the summary statistics, the upper fence and the Q3. The upper fence is basically the 97 point. It's 2.5% data is living beyond this point. So you can see all this. So this is these two are slightly positively skewed, and you can also compare the standard deviation just producing the descriptive statistics as uh, data frame group by gender, and the variable is average glucose, and you are finding the aggregate level mean and standard deviation. So let's see. So these are the standard deviation for male and female, but for this group we have only one observation, so the standard deviation is not produced. And we can see the standard mean is almost twice the standard deviation in these two groups. So we have no strong indication of normality in this data set, but still we are proceeding with independent sample t-test, although independent sample t-test will the two samples should be independent and normal distributed, and yes, we assume the variances are equal. So if we see the standard deviations are not the same, we'll assume with equal variance. And then we just do the analysis using the Welch test that you can perform assuming the variance. difference between the two results obtained from the t-test and obtained from the Welch test. So for applying independent sample t-test, we need to import the states from SciPy package. And then we need to make two variables, two groups according to the grouping, male glucose and female glucose. We have extracted the groups and then apply the t-test. We need t-test and p-value from the command states from the package library states. We are using the t-test command and independent, and the variable is the two variables are male glucose and female glucose. And we are printing the t statistic, this value and p value. You can just change these names and what you want to write. And then you can even interpret your result using the 0.05 criteria. If the p-value is less than 0.05, you will get this interpretation. You can write interpretation in advance, although you can do it later. But if you want to save time, if you have many variables, then you can just change the things here and you can continue with this condition here. So let's do. Here you can see the t statistics is 3.9 and the p-value is 0.0009. It means it is significant. There is a significant difference in average glucose level between male and female. So here we have this interpretation. Now, if the variances are not equal, we just use the Welch test, and we just change the equal variance is equal to false. We use the same command, just we change the equal variance is equal to false, and it will give the t-test for the Welch under Welch approach, and we get the results in similar way. You can just check. Now the t-test statistic is a little bit different, and the value of this the formula for the statistic use the pooled and the variance for Welch just use the individual variances divided by the number of observations, and but the degree of freedom formula is different for Welch test. So the p-value is again 0.001, a little bit higher than it was 0. After 4 zeros, there was 9, and here after 3 zeros, there is 1. So there is a little bit different, but the results are same. So you can then go with either the one approach. Now, you can also apply independent sample t-test for more than one variables. We need to compare, for example, age, BMI, and average glucose level for between male and females. In that case, you can create a for loop. You can first create the gender groups, DF, gender, that is unique. Assuming gender is the grouping variable, you need to just create the gender variable, and then for variables to test, you have just have a list of variables consisting of the variables you want to test. So for variable in this list, print f and performance test. This is just we will display. You will see this on your screen. And then variable. For example, it will give a title for each variable. When the variable change, this value will change. And then group 1 data, group 2 data, you have group 1 data and group 2 data. The variables will be changed, but according to the gender. This is group 0 and this is group 1. We have two groups. And we are dropping NAs. and then t-test group 1 data and group 2 data. So it will iterate for each variable, for uh, all variables one by one. So you can just see the result print, independent sample t-test, and the t-test, t-statistic, and p-value, and, and the test conclusion. Basically, the interpretation of the result based on the p-value. So then you will get these results for each variable. So let's see performance test for age. You will get the result for age, and performance test for BMI. You will get results corresponding to BMI, and performance test for average glucose. You will get the result on average glucose. So that's all about uh, when sample test, and you are going to conduct test on different variables you want to compare, for example, case control or something like that. So trials, you can check different biomarkers in the two groups, treated versus control, and case control studies. You can check the average of different variables in cases and controls. So you can do this type of analysis in cross-sectional studies or clinical trials when you are just observing, uh, uh, comparing the groups. But if you have paired data, for example, before and after certain situations, then an assumption will be violated. And in that case, we need to go for not paired sample details. We have paired operations. One before certain intervention, before a follow-up period, and then after a certain follow-up period. After giving some medication, after applying some intervention, you will get another result. So, in this example, I just tried to create a new variable average glucose 2. That is, I have added a random factor, a random variable with the old average glucose level, and created a new average glucose level. So we have average glucose level before and after on the observation. So we have a paired observation in this case. For paired data, we need to create a paired data. We need to write just the variables you want to use. This is average glucose level and average glucose level 2. And then perform t-test, then just use states and then t-test here a related sample REN. Here you are using in above cases you are using independent sample IND. Here you are using a related sample, and then paired data you have already created data. Uh, from paired data you are choosing glucose level, and from paired data you are choosing average glucose level too. Although you can just use the DF here. You are using DF. You are using this from DF, and you are using this from DF. If these two variables are present in your data set, then you don't need to construct the paired data. If this is already in your data set, you just need to put the two variables, x and y, for example, x1 or x2, and then you to again print the paired sample t-test as title and t-statistic and p-values. And then you will get basically these two values from your test result. And you can just run this. And we can see the test statistic is very small and the p-value is very large, and we can conclude that there is no significant difference between the pair measurements of average glucose level before and after. So if you want to create a significant difference, for example, I am adding the mean as 3. Now the average glucose level will be increased after giving some medication. So average glucose level 2 will be higher than average glucose level 1. And you can see the result. Now it's significant. The statistic is 43.93. This interpretation has changed, and it's now there is a significant difference between the paired measurement of average glucose level. So these are all about the paired sample test, and it depends on. And if you have any question, you can always write in the comment section. And for your attention.